We're going to be talking today about the first direct measurement of the influence of gravity on antimatter. Now, most people, if they've heard of antimatter at all, heard of it in some sort of science fiction-y context. But it really exists. It's a form of mirror matter, which is very uncommon, and we'll discuss this a bit more, very uncommon on Earth. But since it was first postulated and then discovered about 100 years ago, scientists have speculated about how it would interact with gravity. Would it fall downwards like everything else, or might it just maybe, very unlikely, but just maybe, would it have fallen upwards?
How does antimatter behave in gravity?
Well, all the indirect evidence is that it behaves exactly the same as matter. The theory of general relativity says it should behave exactly the same as matter. But until the result today, nobody had actually done a observation that could, for example, rule out antihydrogen moving upwards as opposed to downwards in a gravitational field. So broadly speaking, we're making antimatter, and we're doing a leaning tower of Pisa kind of experiment. We're letting it go, and we're seeing if it goes up or down.
Dr. Wurtele, can you start with what is antimatter?
So antimatter is an interesting history. In the beginning of the 20th century, there was special relativity by Einstein, and then a decade later or so, general relativity, and then a few years later in the early 20s, the development of quantum mechanics. So 3 revolutions in physics over a period of 2 decades. But there was no connection between the quantum mechanics and the special relativity initially. Dirac, by the end of the 1920s and in 1930, he published a paper in which he had connected special relativity to quantum mechanics. And so he had a theory, for example, of the electron, which is consistent with both quantum mechanics and special relativity. But his theory was an equation, and his equation actually admitted a solution which had a positively charged electron as a possible particle. And this was a particle that he basically found in an equation, and he said in his paper, if it's in the mathematics, maybe nature gave it a shot. So you have to understand this is a revolutionary concept. You derive an equation, you see a particle coming out of it, and 2 years later, Anderson, working at Caltech, sending balloons up to study cosmic rays, found a track, the remnants of a particle, which was the mass of an electron, but it was moving as if it had a positive charge. And that is the anti-electron, or the positron. So it took only 2 years between Dirac's prediction and the discovery.